All right, guys, today we have a little extension here for those of you ready for an extra challenge. We have learned how to write and solve equations, but mostly we've written and solved equations that all kind of follow a very similar format. What goes with the x, and then we have something like 5x plus 10 equals, they all turn into two-step equations. So I think you guys are ready for something a little bit more complicated. So you need this page of notes, which you can either print, it's available as a PDF, or you can get a copy from Miss McGowan, or if neither of those work for you, you can really just write all of this down on your own piece of paper, and that is perfectly wonderful. So whatever you're using there, if you have a copy of the notes or a piece of paper, get your pens and pencils, and let's be ready to go. So these instructions should look very familiar to you. We did this with a lot of our problems beginning of last week and the week before, where it says, for each of the situations below, here's all the stuff we're going to do. We're going to assign a variable, we're going to write an equation to represent the situation, we're going to solve the equation, and we're going to relate our answer back to the context of the problem. We've done this before. Like I said, we've just done it in some problems that feel very prescribed. They work out the same way, and those are very useful problems to know how to do. But let's look for a little bit more of a challenge here. Question number 1 said, Kalisa asked her grandpa how old his parents were. So if she's asking her grandpa, his parents are still alive, so she's talking about her great-grandparents. Instead of just telling her, because grandpas are so like this, instead of just telling her their ages, he said, the sum of your great-grandparents' age is 183. Your great-grandpa is 5 years older than your great-grandma. Help Kalisa figure out how old her great-grandparents are. So here's one of the things that's definitely more challenging about this question. First of all, there's actually 2 things that we're finding. So how do we assign a variable when there's 2 things that we're finding? Well, let's give ourselves a tip over here, okay? What is everything based on? Okay, for example, when I read this, it says we're supposed to figure out how old both of her great-grandparents are. So that means we have a great-grandpa and a great-grandma, and that's actually 2 variables, x and y, which gets a little confusing. But if they tell me this sentence right here, your great-grandpa is 5 years older than your great-grandma, that means grandpa is based off of grandma. So here's what we're going to do to assign our variable. We are going to say that x equals the age of great-grandma. We are going to let her be the x because grandpa is based off of her. Now watch this. You ready? Now we're going to get an equation. The sum. Okay, we know sum means addition. We are going to add grandma plus grandpa. Grandpa is 5 years older than grandma, so grandpa is 5 years older than grandma. This is grandma, this is grandpa, because it's grandma plus 5. Make sense? And the sum of their ages is 183. The tricky thing today is getting your equation. That's always kind of the tricky thing, but on this paper it's even trickier than before, because you guys are ready for a bigger challenge. So I have parentheses here, mostly just so I can show you this is grandma and this is grandpa, but really there's nothing to multiply through here. This is just going to be a cleanup of combining like terms. This is now x plus x, which is 2x plus 5 equals 183. Now we are totally ready to solve this. Here we go. Minus 5 minus 5. This says 2x equals 178. Should have written this over here, but now we're going to go divide by 2, divide by 2, 178 divided by 2, well, 180 divided by 2 would be 90, 178 divided by 2, 89, 183 minus 5, yeah, 89 years old. Okay, so if I just got x equals 89, I just found out grandma. Okay, so great-grandma, I'm going to put this, great-grandma, grandma is 89 years old. And what about great-grandpa? How do we figure out great-grandpa? Oh, wait, he was X plus 5, right? 5 years older than grandma. So 89 plus 5, 94 years old. Now, there's one more thing we can do to double check and make sure this makes sense. The sum of their ages was supposed to be 183. So let's check it out. 89 plus 94 is 183. More complex. All right, let's try another one. Number 2. Peter tends a total of 87 sheep. Probably not. Probably sheep and goats. Probably. Okay, Peter tends a total of 87 sheep and goats. He had 15 more sheep than goats. How many sheep and goats does Peter have? Once again, what is based off of what? And the idea is you can really do it either way. We could base the sheep off the goats or the goats off the sheep. You really can do it either way. That's why it's so important that you decide in the beginning and stick with it. So if it says he has 15 more sheep than goats, this sounds to me like sheep is based off of goats. So I'm going to say that X equals number of goats. Okay, and then the note that I'm going to make over here, just to make sure we're really clear, if X is the goats, then sheep, 15 more sheep than goats. Sheep is going to be X plus 15. So this is goats here. This is an expression for sheep. And now I've written this word and seen it a lot of times, and that word looks very weird to me. But I'm pretty sure that's what it is. So he has a total of 87 sheep and goats. So we're going to do goats plus sheep. And I'm not multiplying by anything, so I don't really need them in parentheses. But I want you to recognize that this is goats. This is sheep. 15 more than goats. Is a total of 87. Okay, let's combine like terms. X plus X is 2X plus 15 equals 87. Now I'm ready to solve this thing. Minus 15 minus 15. 2X equals 72. Yeah. Divide by 2, divide by 2. And X equals 36. There's my actual solution to the equation. But let's finish off our answer here. I wanted to know how many sheep and goats. What did we just find here? Oh, we just found goats. 36 goats. How many sheep does Peter have then? Oh, all I have to do is take 36 and add 15 to it. So that's going to make 51 goats. And then, of course, I can check this by adding them together. Is 36 plus 51 equal to 87? Yes, it is. So Peter has 36 goats. No. Goats and goats. I'm struggling with this word, I'm telling you. Sheep. See, it looks so weird to me that I didn't want to write it again. 36 goats and 51 sheep. Sheep. Sheep, sheep, sheep. All right, here we go. Peter's neighbor. So Peter has all the sheep and goats. Peter's neighbor raises chickens. They have hens and roosters. That's females and males. I have some chickens at my home, but when you live in a city like Taylorsville, you're not allowed to have roosters. You can have hens, but no roosters. You know why? Because they're way too loud, way too early in the morning. But Peter's neighbor has them both. Their family sells the eggs, so they like to have 4 times as many hens as roosters, because the roosters don't lay eggs. If they currently have 45 birds, how many of the birds are hens? Okay, let's check this out. 4 times as many hens as roosters. Sounds like hens is based off of roosters. So I'm going to say X equals number of roosters. You getting the idea here? These questions are a little trickier because you're asked more than one thing, so you have to really carefully choose what X is going to represent. And then we also, okay, we're going to say, all right, if X is roosters, let's make an expression for hens. 4 times as many hens as roosters. 4 times as many, not 4 more, that would be addition, but 4 times as many. Okay, we're ready to make an equation. They currently have 45 total birds, so here we go. Roosters plus hens equals 45. Oh, that's pretty easy now. All I gotta do is combine those. 1x plus 4x is 5x equals 45. Now I'm ready for my inverse operations. Divide by 5, and x equals 9. Okay, see if I can get it right this time. What did we just find out? X is 9. 9 is roosters. Peter's neighbor has 9 roosters. How many hens would that be then? Oh, 4 times 9 is 36 hens. So these problems got a little bit trickier because there were 2 things that you were trying to find, and so we had to figure out what was based off of what, so that we could define x and then kind of make an expression for the other one based off of x. Okay, you'll practice some of those on your Canvas quiz. Let's look at number 4 and see how else these get tricky. Number 4 says you are selling handmade jewelry at a craft fair. You spend $5 for a chain, so that's just the chain part, plus 35 cents per bead to make the necklace. That's how much you spend to make this. You know that you can sell that necklace at the craft fair for $30. How many beads should you put on the necklace if you want to earn twice the cost of making the necklace? This is very similar to how we started our multi-step equations with pearl knitting hats. So this one is a little bit more clear what x should be. There's only one thing they're asking me. They're asking me how many beads. Okay, to start my equation, I'm going to go $5 for the chain plus 35 cents per bead. How many beads goes along with the cost per bead? I know I can earn $30 for this, but I also know that I want that $30 to be twice the cost of making it. So I'm going to take all of this and times by 2 before I set that equal to $30. Another option is you could absolutely cut the $30 in half. But for the sake of practicing distributive property, we're going to write our equation like this. And that is precisely what I need to do first. I'm going to distribute. So 2 times 5, this is my cleanup step. 2 times 0.35 is 0.70 or 0.7, 70 cents, equals 30. Now I'm ready to go minus 10 minus 10. And I'm going to come right over here. This is 0.7x equals 20. Divide by 0.7, divide by 0.7. Now, one of the things that happens in these more complicated types of equations is that these numbers don't always turn out very nice. That's very real world numbers right there. So if you see this answer and you know your situation is about how many beads, well, it makes a lot of sense to go to the nearest bead. Now, technically, yes, this would round up to 29. But if you're trying to stay under a price, then you don't want to round up. So you can use 28 beads. If you do more than 28 beads, then you're not earning twice the cost of making it. So that was just a little bit more complicated because it had some distributive property in it. All right, last one. You go to a department store and buy a pair of pants that are 30% off the original price. The store is also having a sale where everything in the store is 50% off. What is the original price of the pants if you end up paying $22.75 for the pants? Okay, well, here's one thing I'm sure of. What is the original price of the pants? So X equals original price of pants. Here's another thing I know. I'm pretty familiar with this. The pants are 30% off. Well, that looks like this. We've done this a lot, 30% off. But the store is also having a sale where after this happens, it's also 50% off. 50% lucky is a nice number that you don't have to subtract it. 50% off means you pay 50%, 50-50. So what I can do is take all of this and times it by 50%. That ended you with $22.75. All right, here we go. Distribute 0.5x minus 0.15x, right? 0.5 times 0.3 is 0.15 equals 22.75. Now I combine like terms. That's going to be what, 0.35? That's kind of interesting. That means you end up paying you end up, if you get 30% off and then you get 50% off after that, you end up actually only paying 35% of it. It's interesting, right? That's what that means. So this goes 22.75. So I'm going to do divide by 0.35, divide by 0.35. And I'm going to type that in my calculator just to make sure. So 22.75 divided by 0.35. Ready? Oh. X equals 65, which means the original price of the pants was $65. All right. A little bit more challenging to model with the equation. The tricky part is setting up the equation. Once you get there, you know how to solve it. So you're going to practice a few of these a little bit more complicated equations. If you have any questions, of course, please let me know.